So first, looking at substitution, anytime you have this situation right here where it's a variable equal to whatever, substitution is most likely going to be the easiest method. Okay, because now all I have to do is take 2x and I'm going to plug that in for y right there. So I end up with x plus 2x equals 12. Are the parentheses doing anything on this? No. There's nothing in front to distribute. It's not being raised to a power. So I can combine my like terms as if there were no parentheses, and then I divide by 3. Once I find one variable, how do I solve for the other?
Plug it in.
Just plug it back in. Okay. If I'm looking for y and I have an equation that is already set up as y equals, use that equation. That's going to save you some legwork. Okay. Then 2 times 4 is 8. Okay. So going down to number 1. Again, I've got a equals right there. So I'm going to substitute 3b minus 20 in for a into the second equation. So I'm starting off with 3b minus 20 plus b equals 12. Are the parentheses affecting this problem? No. So I just combine my like terms. Combined 3b and b. Okay. And then, Mr. Kreitz, what do I need to do next to solve for b? Add 20 to both sides. And then do what, Connor? Divide by 4. Once I find that one, both equations are pretty easy to plug b back up into. Okay, I would probably do the second one. So a plus 8 equals 12. Then all I have to do is subtract 8, and a is 4. Negative 2 times negative 4 equals 18.
Can you write it like that too? The opposite.
On this one, you should have gotten that p is 5 and t is 2. What is different about number 3 than the other problems we've done? Yes, Max?
They both take x, y, and it equals a number.
Okay. Yes, that's kind of getting at the answer I want. Somebody else have another answer to that? How is that different than the other ones that we've done, Garrett?
You have to do, you have to divide, subtract x to the other side. Like you have to get x by itself.
Okay, there you go. So you don't already have a variable that's solved for. Okay? On the very first example we did, up in the box, we had y equals. On number 1, we had a equals. On the last one, you had both t equals and p equals. On this one, you don't have that, so you have to make that, essentially. All right? Now, to make these problems easier, you need to figure out which one of these 4 variables are going to be the easiest to solve for. Okay? Anytime you have a variable that has a coefficient, which, if you have no idea what the word coefficient means, raise your hand. We need to get that cleared up now. Okay. Coefficient is just the number that is in front of a variable. Okay, so the coefficient for this one is -3. The coefficient for that is 2. So if you have a term that does not have a coefficient, this x or that x, you need to solve for that one. It will make your life much easier. Okay? Yes, Garrett?
Elimination.
We'll talk about elimination on the back. You'll need to know how to do both. So I'll take that first equation and I'm going to add 3y. So I end up with x equals 3y minus 1. Then I want you to take that 3y minus 1, plug it in for that x, and go ahead and solve that system. These parentheses aren't doing anything on this one. You should have found that y equals 2. Somebody tell me which one of these equations would be the easiest to use to solve for x. The red one, the green one, or the blue one? The blue one. Because if I'm solving for x and I already have an equation that is set up as x equals, all I'm going to have to do is plug in the y value. If I would have used one of the other problems, or one of the other equations, then I would have had to move some stuff around after I plugged it in. Okay, but that makes that one a little bit easier. Alright, let's go to number 4. It says an art class is planning a trip to a museum. Of the 22 people going on the trip, there are 4 drivers and 2 types of vehicles, vans and cars. The vans seat 6 people. The cars seat 4 people, including the drivers. How many vans and cars does the class need for the trip? So what do my variables need to stand for? What do they need to represent? What about vans and cars? Not the number of seats in them. The number of cars and the number of vans that they need to take. Always look at the question that's in the problem. That will help you figure out what those are. I did switch that for some reason. That would be really confusing. Can somebody tell me what one of my equations would be for this problem? Okay, keep going. What would that equal? Somebody else tell me. What'd you say? 22. The number of people going. 6 people in the van, 4 people in the car. There's 22 total people going. What would my other equation need to be? If it helps you out, we've used this piece of information, and this piece of information. We identified the vans and cars. What other piece of information is up there? 4 drivers. So what would the equation be? V plus C equals 4. The number of vans plus the number of cars equals 4. I can't take 5 because I only got 4 drivers. Can't take more than 4 because I only got 4 drivers. Somebody tell me why these 2 variables in the second equation are going to be easier to solve for than the 2 variables in the first equation. They do not have coefficients. So I'm going to take that second equation. I'll solve for V. You can solve for C if you want. Subtract C to the other side. And then I'm going to plug that in for V into the first equation. So go ahead and finish that problem. So you may need to see that one worked out. Okay. So I'm going to plug that up into there. So I'm going to have 6. Instead of V, I'm going to have 4 minus C plus 4C equals 22. Distribute my 6. Combine my like terms. I'm also going to subtract 24. Negative 2 divided by negative 2 is 1. I can plug that back into the V plus C equation. And 4 minus 1 gives me 3. Sorry. Going down to the next problem. We're just going to set this one up. Just want to kind of talk about it. It says you have 14 coins in nickels and dimes. If your coins total $1, how many of each do you have? So whenever you're identifying your variables, had someone start doing this last year. If you want to do this, okay, that's fine. But just be aware what the question is. Okay, it's number of nickels and number of dimes. Got that, Carlos? Yeah. Alright, so what is one of my equations going to be on this one?
5 and 10D
Okay.
equals 1, 0,
Don't need any decimals in there?
1.0.
Okay. So if it's 5n plus 10d equals 1.00, where else do I need decimals? But where else do I need decimals?
In front of the other numbers.
Okay, so is it 0.10 and 0.5? 0.05. And we're going to talk about that problem here in a minute. Why then you're just putting the value of each coin in front of it. That's all it is. It's how much they're worth. Yes.
Sir, can you just change the $1 to 100?
That's what we're going to do. Alright, so on that first equation, and this is why I wanted to do this problem, because these problems are common, the money and the number of coins and the value, all that stuff. If you do not want to deal with decimals, which most people would prefer to deal with whole numbers than decimals, you can think in terms of pennies. So how many pennies is a nickel worth? How many is a dime worth? How many pennies are in $1? Those two are going to be the same, give you the same answer. It's just that the second one is going to give it to you in terms of pennies. So if you get $532, it's not $532, it's $5.32. You just need to know that. Okay? You take the decimal out at the beginning so that you can deal with whole numbers. You just got to put it back in at the end. Okay? Okay, looking at the back. Doing this by elimination. Okay, if you're going to do this by elimination, you're setting up the equations right on top of each other. And you're going to think of it as just basic addition problems. Some turn into subtraction if you got negatives. By column. Just like that. Okay, and then you want one of the variables to cancel or eliminate, hence the name elimination. So on this problem, what variable is going to eliminate? The y's. Okay. 5x plus 3x is 8x. And then you got negative 80 right there. Okay. Then you just solve for x. Once you have that one variable, you plug it in and solve for the other. You can do it into either one, into either equation. I just did the first one. Yep. So x equals negative 10, so I just put that in there for x. It's going to give me negative 50 minus 6y equals negative 32. Okay, and then just solve for y.
Whoa there, Kimosabi. What happens if the y's cancel out?
Quickly, yes. Yeah, multiply the second equation by 2 so that I can get 6b and negative 6b. No, it's whatever you need to multiply it by to cancel that out. To cancel one of them out. Because 2 on here, because if this is 6b, I can change that to negative 6b by multiplying it by 2. If this was negative 2b, it would be multiplied by 3 to get negative 6b. If you're following along with me up here, I'm rewriting the first equation just so I can have the two equations stacked on top of each other. Okay. So there is A. I want you to solve for B and then also do number 8. Do not think you did it wrong if you get a fraction.
San Francisco.
Yes.
You know where I want to live when I retire?
It's kind of like a oh yes.
Bro, and I'm not really.
So on this one it says your class receives $1,084 for selling 205 packages of greeting cards and gift wrap. So there are my variables. Gift wrap cost $4. Cards cost $10. Use a system to find the number of each type of packages sold. So what would one of my equations be? 4G plus 10C equals what? Okay. What would my other equation be?
G plus C equals 205.
Okay. Now on this one, I would multiply the second equation by -4 instead of -10. I would cancel these out only for the reason of if I multiply by 4, I'm going to have smaller numbers than if I multiply by 10. That is the only reason. If you want to multiply by -10, that is fine. So I've got -4G
Why does it be negative?
because I need a -4G because this is a positive. 4G minus 4G is going to cancel. Equals -820. And then now I'm working with these two equations. So the G's cancel. 10C minus 4C is 6C. 1084 minus 820 is 46264. So I'd have 44 gift cards. And then you can plug that back in. I would plug it in, and someone, I think it was Connor. Connor asked me this early on a previous question. Whenever you plug this in, plug it into the original equation right here without that -4. Okay, that's going to be the easiest one. So you got G plus 44 equals 205. And so the number of gift cards is going to be 161.